Hey guys, this is part 2 of transformations of trig graphs. In here, we're looking at transforming cos and tan. If you haven't checked out part 1 yet, go back and play with that one first. In there, we go over a brief recap of our different types of transformation, and you can also download my transformations PDF. It's a good time, and we also transform y cosine of theta in that. So I'll put a link to part 1 down below this in the description. Here though, we are going to be transforming cos and tan. Let's get cracking. So before we start transforming it, it's a good idea to make sure we're really happy with the graph of cos of theta. So this is it. So we intercept the y-axis at 0, 1. Positively, our x-intercepts are at 90 and 270. Our trough is at 180 degrees, and that has a y value of -1. So cos, just like sine, has a period of 360 degrees. A period basically means how far we go along the x-axis before the graph starts repeating itself again. So by the time we get to 360 degrees, the graph just repeats what it's done in the last 360 degrees. So negatively, we are symmetrical about the y-axis. So we intercept x at -90 and -270, with our trough at -180, again at -1. So this is the graph that we're going to be transforming. Make a note of it. Let's get going. Okay, so for our first one then, we want to sketch y equals -2 cos theta in our usual interval, -360 to 360. So what type of transformation is this? Well, -2 is multiplying the whole function. So it's a stretch and a reflection in the x-axis. So what's going to happen here is every y coordinate is going to get multiplied by -2. Our scale factor is -2 on the y coordinates. So let's go through this. So this first peak here is at 361. That's going to reflect down to -2, which we're going to say is there somewhere. We're then going to go through the x-axis. 2 times 0 is still just 0. This trough at -180 -1 is still going to be a -180, but the y coordinate -1 is going to get multiplied by -2, so it's going to be up here somewhere. We're going to go through the x-axis at -90. Our y-intercept is now going to be down at -2. Then we're going to go through the x-axis at 90. What was our trough at 180 is now going to be a peak up at +2. And then we're going through the x-axis again, and then our last point will be at 360 -2. So there are our points. Now I'm going to draw it. Okay, so it's nice to see my drawing is on point. As always, it doesn't really matter what your sketch looks like, as long as it makes sense in relation to any other graph that you've got already drawn. So here I had cos theta drawn, so it does matter that minus 2 cos theta makes sense relative to cos of theta. And it's also important to label your graph. So this is y equals minus 2 cos theta, and also label some important points. So the coordinates of this peak would be minus 182. The intercept is now down at minus 2. This peak over here would be 180. 2, and then this trough down here, it would be 360 minus 2. So there's our sketch of minus 2 cos theta. Good times. Okay, for example 2, we want to sketch y equals cos of theta plus 45. So the 45 is inside the function, it's being added to theta. So this is a translation. It's translation. It's going to take us minus 45 along x. So the vector is minus 45, 0, like that. So none of the y coordinates change, only the x coordinates, so they change by we minus, or they go 45 degrees to the left. So this guy here at minus 270 is going to go to minus 315. This peak that would be minus 180 is now going to be at minus 225. Still going to be at minus 1 though. The x-intercept at minus 90 is now going to be at minus 135. The peak here that was at 0 is now going to be, say, here at minus 45. Still going to have a y coordinate of 1. This x-intercept at 90 is now going to be at 45. This peak, this trough down here that was at 180 is now going to be at 135. Y coordinate is still minus 1. This x-intercept that was at 270 is now going to be at 225. And then finally, this peak is now going to be 45 degrees back from 360. So it's going to be 315. And then the y coordinate is still 1. So those are the points we need to plot. Let's join them together. Okay, so there's the sketch for our graph. So again, nothing has changed with the graph. The shape hasn't changed. The y coordinates haven't changed. It's just been translated 45 degrees to the left. Okay, now then, we want to do y equals cos of 3 theta. So first of all, what type of transformation is this? Well, theta is being multiplied by 3, So this is actually going to be a squash along the x-axis. Now, the scale factor is 1/3. So the scale factor is 1/3. So every x-coordinate on cos of theta gets multiplied by 1/3. Now, this might be a good time to start talking about the period of a graph in a bit more detail. So, when we were back on the cos graph, I said the period of cos of theta is 360 degrees. So every 360 degrees cos of theta so going from 0 to 360 degrees and then 360 degrees to 720 degrees, that will be an exact repeat of the graph between 0 and 360. So given that cos of 3 theta is a squash, we're going to have a smaller period. So to find the period of cos of 3 theta, we divide the period of cos of theta by 3. So the period of cos 3 theta is 360 divided by 3, which is 120. So cos of 3 theta is going to repeat itself every 120 degrees. The reason for this is multiplying theta by 3 makes the graph happen 3 times faster. So whereas with cos of theta we can get one cycle or period in 360 degrees, with cos of 3 theta we're going to get 3 whole cycles. Okay, let's deal then with the positive part of the graph. First of all, we then know, because we're dealing with cos, the graph is symmetrical through the y-axis. So, we're still going to have this point at 0, 1. That's still going to be our y-intercept. Now, our first x-intercept is going to be 90 divided by 3. Now, 90 divided by 3 is 30. So say we're going to be there roughly. Now our next important point is the x-coordinate, or the coordinates of the trough of the graph. Now that trough happens at 180. Or cos of 3 of theta is going to happen at 180 divided by 3. So 60. So that's going to be about that. And then our next x-intercept is at 270 on cos of theta. Divide that by 3 for cos 3 of theta and we get 90. So that's going to be there. And then our next important point would be the peak, which is happening at 361. So that's now going to happen at 121. So that's going to be about there. So far if we stop there and join that up, we've got one period or one cycle of cos 3 theta. Okay, so that's how we're looking so far, but obviously we can't stop there because we want the graph in the interval minus 360 up to 360. So we have to go all the way to the end. Luckily though, there is a pattern. Every important point happens 30 degrees after the last one. So we've got our y-intercept at 0, x-intercept 30, trough 60, x-intercept 90, peak 120. So the next thing to come after that is an x-intercept at 150. And then the next thing is a trough at 180. Next thing is a x-intercept at 210. Next thing to come is a peak, and that's going to be at 240. Next thing to come is an x-intercept, that's going to be at 270. Next thing, trough, 300. Next thing, x-intercept, 330. And then lastly, a peak at 360. So, if we join all of those up, that's going to give us our graph in the positive part of the x-axis. Okay, so there's how it's looking on our positive part of the x-axis. So we got peaks at 0, 120, 240 and 360, and troughs at 60, 180 and 300. Now, let's also go through and label the x-axis. So, you can see we got the first two in 30 and 90. So, on the normal graph, because of theta, the x-intercepts are 180 degrees apart. So on cos of 3 theta, that distance is going to be reduced or divided by 3. So it's going to be a third of the size. So the distance between x-intercepts is 60. So the next one is going to be at 150. The next one after that is going to be at 210. The next one is at 270. And then the next one is at 330. So there is the sketch of our graph, cos 3 theta. So given that the graph hasn't been translated at all, it's exactly symmetrical through the y-axis. So all of the coordinates are the same, except the x ones are negative. Good times. Okay, last one for cos. So we want to sketch cos of theta plus 1. So the plus 1 is not involved in the function, it's after the function. So this is a translation up by 1. So the vector is 0, 1. So every y coordinate is just going up by 1. So the peak that was at minus 361 is now going to be a minus 362. What was the x-intercept is now going to be up at 1. The trough is now going to be on the x-axis, then the intercept is going to be up at 1. The y-intercept is going to be up at 2. And then the next x-intercept is going to be a 1. The trough sits on the x-axis. And the next intercept is a 1. And then finally, our last peak is up at 2. So there are our points. Let's join them together. Okay, so that's how he's going to look. Exactly the same graph. It's just all moved up by 1 place. So the troughs of the graph now sit on the x-axis, and the peaks are now at y equals 2. Okay, now lastly we're going to do a couple with tan of theta. So remember the graph tan of theta between minus 360 and 360 looks like this. So we have asymptotes at 90, 270, minus 90 and minus 270. Remember now, even though your trig identities, you should be aware of why this is. It's because tan is sine divided by cos. At these points, cos is 0. So you're trying to divide by 0, which you can't do. So we're going to do 2 questions with tan. First up, we want to do y equals minus tan theta. This time though, because tan is such a boolean, we're only going between minus 180 and positive 180. So, minus tan of theta is just a reflection in the x-axis. So, we're going to have exactly the same asymptotes. So down here again is our time graph. So we're only going to need the asymptotes at 90 and minus 90, because we are only going between minus 180 and 180. So that is going to be our asymptote for minus 90. And then we've also got on at positive 90. So this guy is a 90. So minus tan theta is a reflection in the x-axis. So we're just reflecting this guy. So it's actually going to go something like this. So, where tan of theta is positive, minus tan of theta is negative, and vice versa. So, hopefully you can see it's a mirror image of this guy. So, we've got, this would be 180, and this point back here would be minus 180, where it cuts the x-axis. So that would be a nice sketch of y equals minus tan theta. Okay, lastly, we're going to sketch tan 2 theta between minus 180 and positive 180. So, what sort of transformation is this? 2 is multiplying the theta. So, this is a squash along x with a scale factor of 1 over 2, so 1/2. So every important x coordinate gets multiplied by 1/2. So let's first of all think about the asymptotes. So the first asymptote is at 90 on tan of theta. So we're going to halve that for tan of 2 theta. So the first asymptote is going to be at 45. Now we're also going to have one at minus 45. Okay, so on tan of theta, the asymptotes are 180 degrees apart. On tan 2 theta, they're going to be half of that distance. So half of 180 is 90. So the next asymptote is going to be at 45 plus 90, which is 135. And then we're going to have the same, but negative down here at minus 135. Okay, so other than that then, well, the x-intercepts will also change. So the first positive x-intercept of tan theta is at 180. So that is now going to be at 90. The second one is at 360. So that's now going to be at 180, and then that's exactly the same negatively. So we got 1 there, which is at minus 90, and then the other one at minus 180. So now we got those in, really the graph looks exactly the same. So it's going to be like that for that part through the origin, and then this bit is going to go like that, and then finally that's going to be like that, and then in the negative part we're going to go up like that, and then the last part goes up like that. So that's what tan of t theta looks like between minus 180 and positive 180. Okay, that's it for this video. So now we got all the tricks that we need to be able to start solving trigonometric equations, which is what we're doing next.